Alright, so today we're doing 10.4, which is solving quadratic equations by factoring. So this is, you're going to use factoring when b is not equal to 0. Remember, when b is equal to 0, I do not want you to factor. I want you to use the square root method. Okay? But before we start doing that, I want to introduce what's called a zero product property, and we are using this property to solve by factoring. Okay, remember, solving is to find where the parabola crosses the x-axis. That means that y is equal to 0. Okay, zero product property says if you have a times b, if that is equal to 0, then a can equal to 0, right? If a is equal to 0, would it make the whole thing equal to 0? Yeah, it doesn't matter what b is, right? As long as a is 0, the whole thing is 0, right? Okay. Or I could let b equal to 0, right? So if a is something else and b is 0, anything times 0 is 0. So a or b could either one to be 0. So that's a zero product rule. So the way we're going to use it is this: if you, after you factor, or if they will factor it for you, this is like your a, this is like your b, right? So this means that I can make this equal to 0. So if this whole thing is 0, wouldn't it make the whole thing equal to 0? Right? And then what if this whole thing was 0? Wouldn't it make the whole thing equal to 0? Yeah. Okay? So this is what you're going to be solving for, to solve. To solve by factoring is, you're solving for x with where it would make this equal to 0. And if you notice, there's two answers. Right? This one would be what? X equals what?
-2.
-2. And what would this equal?
3.
3. So those two numbers would make this whole thing equal to 0. Because if I plug in -2, -2 plus 2 is 0, times -2 minus 3 is -5. So what's 0 times -5? 0. Or if I plug 3 in, 3 plus 2 is 5. 3 minus 3 is 0. So what's 5 times 0? 0. So you're looking for two x's that will make this whole thing 0. By doing that, you're looking for, so these are the 2 points where the parabola, so if I were to draw a parabola at -2 and at 3, that's where the parabola is going to cross the x-axis. That's what we're solving for still. Okay? But now, instead of the square root method, because b is not 0 here, you have to factor. And there are 4 methods for solving quadratic, because not every function is factorable. So that's where the completing the square and quadratic formula comes in, which we're going to learn in section 5 and section 6. Okay? So here's example number 1. They're going to say solve. So whenever they tell you to solve, you're looking for the x-intercepts, where the parabola crosses the x-axis. So you want your y. So this one they already factored for you. And they already set the y equal to 0. Because you always have to set it equal to 0. Because on the x-axis, y is always 0. So this is 0. Okay? So now using the zero product rule, we're going to set that equal to 0, right? 2x plus 3. If that was 0, the whole thing is 0, right? And then the other one will be x minus 4, set that equal to 0. So if this was 0, the whole thing would be 0. So now I want to know what those two x's are to make this whole thing equal to 0. And where my x-intercepts are. Okay? So now let's do this one first. What do we do first?
-3.
-3. So then I get 2x equals -3. And then what do we do? Divide by 2. So x equals -3 over 2, or -1.5. So -3 over 2 comma 0 is my first solution, right? Let's come over here. What do we do to both sides? Huh? +4. So then x equals 4. So my solution is at 4, 0. Those are my x-intercepts. That's where the parabola crosses the x-axis. That's what you're doing today. Okay, so this one's already factored for you. Now let's find one that's not factored for you. Okay, so that's example number 2.
Do we have to graph them after?
Nope, you do not have to graph, but please do understand what the answer stands for. When you solve this, you found the points on your graph where the parabola crosses the x-axis, okay? That's what you're solving for. All right, let's solve. 3x squared minus 2x equals 21. So they gave you this. Remember, when you're solving, it has to equal to 0. Is this equal to 0? No, I want to make this become 0. How do I make that become 0? Minus 21. So what we're going to do is, if you're going to minus 21 here, you have to do it to the other side. So minus 21. Okay? Are these like terms? No, they're all different terms, right? So you just put them next to each other. 3x squared minus 2x minus 21 is equal to 0. Now it is equal to 0. Now we want to factor. Bless you. All right, let's factor. So remember when we're factoring, a is equal to? What is it? 3. B is equal to? Negative 2. And C is equal to? Negative 21, right? So we're going to multiply a times c, which is 3 times negative 21, which is negative 69. And I want the sum to equal negative 2. So what times, oh, 63, not 69, sorry. Now what times what is negative 63 that would add up to negative 2? What are my factors? What times what is 63? 9 times 7. So we know it's 9 times 7. But I want it to be negative 63. Which one has to be negative so that it would add up to negative 2? Negative 9. Because negative 9 plus 7 is negative 2. So those are my factors. Okay. Now we come over here and split. So this is a quick review of factoring. So 3x squared minus 9x plus 7x minus 21. And that's still equal to 0. After we split, we group the first two, group the second two. What's my greatest common factor between 3x squared and 9x? 3x. So 3x. So remember, Emma said you have to bring it out, right? So now 3x squared divided by 3x is x. 9x divided by 3x is minus 3. And what's my greatest common factor between 7x and 21? 7. So remember, we pulled that out. Plus 7 comes out. And then I get x minus 3 equal to 0. And if you notice, these are exactly the same. So you know you did it right. So we factor one more time. So I get 3x plus 7, x minus 3. Those are my factors. Now we're at what we did in example number 1. Now we solve. Okay, so now what you got to do is you take each one of them and set it equal to 0. So we got 3x plus 7, set that equal to 0. And then we got x minus 3, set that equal to 0. And then you solve for x. So for this one, you subtract 7. 3x is equal to negative 7. Divide by 3. So x is equal to negative 7 over 3, or negative 2 and 1/3. So negative 7 over 3, comma 0 is one of my x-intercepts. That's where the parabola goes through the x-axis. This one now, add 3 to both sides. X equals 3. So 3, comma 0 is my other x-intercept. And that's where the parabola crosses the x-axis. Okay? Any question with those? So now let me show you. So I'm going to do it with the easy problem. So if I ask you to solve, and you got x squared plus x minus 42 equal to 0. Now, I want to show you how to factor this without doing the ABCs, sum of B. This is where I want you to get to eventually. Okay? So remember when you're done factoring from going from here to here, see how it creates those two sets of parentheses? So that's what I would do first. So do your little two parentheses. Okay? Now this one's easier because a is 1. So what times what is x squared? X and x. So that's what goes in there. Now what times what is 42? 7 and 6. Now which one has to be negative and which one has to be positive? Because I want this and this has to add up to positive 1. So 7 has to be positive, 6 has to be negative, and those are your factors. So now you set that equal to 0, set that equal to 0, and you solve for x.
You only do that one.
Nope, I'm going to show you, I'm going to do it again for the other one. When I ask you, to, like, I'm going to go back to example number 2's problem, I got 3x squared minus 2x minus 21, right? So I'm going to show you how to do this without the ABCs, and grouping and factoring. Alright, so you're going to do it again. Ready? Same thing again. What times what is 3x squared? Well, 3 can only be divided by 3 and 1, right? 3 times 1 is 3. So you just do 3x and x. 3x times x is x squared, right? Now, what times what is 21? 7 and 3, right? So now I'm going to do this. I'm going to put the 3 here, and I'm going to put the 7 here. But one of them has to be negative, one of them has to be positive. But before you decide, did I put this in the right spot, you got to look at these two, which is 3x, and you got to look at these two, and that's 21x. Do the difference between those two give you negative 2? No, it's 20, what is that? No, 19, right? So that means I put those numbers in the wrong spot. So what you're going to do is you're going to change spots. 7 and 3. Now let's try. 7x and 9x. Is the difference 2? Right? Difference is 2, right? Between 7 and 9, difference is 2. So now I want to make it negative 2. So which one has to be negative? Negative 9 or negative 7?
Negative 9.
Negative 9. I want it to be negative 9. So this has got to be negative. This has got to be positive. Okay, so you got your 7x, negative 9x. They add up to negative 2x. So those are my factors. And that's what we got when we factored up here, didn't we? See right here? 3x plus 7, x minus 3. So I want you to eventually get to this point where you are factoring like this instead of doing what we did in chapter 9.
Why would
Okay.
we get taught that last one if that's way too hard, and then like we can just do that?
Because of that, you could do this.
But
You got to be able to know how to do this and understand that part to get to this point. That's why. Okay? Even in calculus, what we do is when we take the derivative, we do it the long way, and then there's a short way to do it, which is so much easier. Okay? Last example. Example number 4. It's a word problem. Okay? This one I used out of the book. It's on page 574. It was number 27. They said they had a square. Okay? I have a square. And it had a length of x. Okay? And it is a square. They said that this square, the size increased by 3 centimeters. So when it increased, my dimensions became x plus 3 by x plus 3. Alright, so the length increased by 3 centimeters. The area of the big square is 64. Okay? So how do I find the area of a square? Length times width. So x plus 3 times x plus 3 should equal 64 because the area is 64. So that's how you set this up. This is not equal to 0, is it? No, so you can't solve this as is, so you gotta FOIL it out first. So x times x is x squared, x times 3 is 3x, plus 3x, plus 9 equal to 64. These are my like terms, so x squared plus 6x plus 9 equals 64. So you gotta factor first, and now how do I make this equal to 0? What do I have to do to
Minus
this?
64.
So I'm gonna minus 64, minus 64. Those cancels out. Now it is equal to 0. So I got x squared plus 6x, and then 9 minus 64 is negative 55. Okay, so you got to make it always equal to 0 first. Now let's factor. And let's do it the short way. Ready? So put two parentheses. All right, what times what is x squared? X and x. What times what is 55? What is it? 11 times 5. So I'm going to put 11 and 5. Now I want this and this to add up to 6x. And I want it to be negative 55. So I got to figure out which one's going to be negative. Is 11 going to be negative, or is 5 going to be negative? 5 is going to be negative because this gives me negative 5x. This gives me 11x. 11x minus 5x is 6x. So those are my factors. So everybody understand how I got that? Okay, so now we're going to set, using the zero product rule, I'm going to set x plus 11 equal to 0 and x minus 5 equal to 0 because we have to solve. So this one I got to subtract 11. X is equal to negative 11. Because we're looking for dimensions of a square, my length cannot be negative, so negative 11 is not a choice. Because I want to know what was the original dimension. So when I add 5 to both sides, x is equal to 5. So the original dimension of the square was the length of 5 centimeters. This was 5 centimeters when you solved it. Okay? But that's what you do with the word problems like this. Okay. Another type of word problem that you will see today, and which I'm going to talk about tomorrow, is remember when we threw a ball up in the air?
Yeah.
And we found how high it went? What you're going to find by factoring is when did it hit the ground? That's what they're going to be asking for. Okay, so you do exactly the same thing to find this point right here. Okay? Any questions?
No.
All right, I have